All right. Why do they have to put this disclaimer here where this polynomial cannot equal 0?
Because you can't
divide by 0. We're going to start learning as far as what that means, and we're going to have to actually identify what excluded values are, which is actually what we're about to get into. So you always want to make sure that you know and you can identify where it's going to be. So looking at this particular example, that looks really small. 3x squared plus 5 all over x plus 7. What would x have to be in the denominator for that polynomial to be 0? For x plus 7. What plus 7? Yeah, negative 7, right? Was negative 7, that would make that 0, right? So one of our excluded values ought to be 0. So x cannot be equal to 0. Like x can be anything else, but it cannot. Okay? This one's a little different. We already factored out an x. What about the inside? Have we factored? We got a trinomial. My coefficient is 1, right? I should be able to factor that. So what do you think my numbers need to be? Give me factors of 3, but if I add them together or subtract them together, I get 4. 1 and 3. And to get a positive, I have to be positive, right? Because we have a positive 3 and a positive 4. So if I did the outside terms to the inside terms, I do get a positive 4x, and then if I multiply my 3 and 1, I do get positive 3. Seeing it in factor form is a lot easier to see what x cannot be, right? So let's pick on this term here. So x, if I set that to 0, can it be 0? No. Nope, x cannot be 0. So I know that that's one of my excluded values. What else can x not be? What about that one? If I set that equal to 0 and I subtract that 3, x cannot be what? Negative 3. 3 plus 3 gives me 0. So it can also not be a negative 3. What about this one right here? It can't be what? Negative 1. Normally, I asked you, what are your x-intercepts, right? Where are they 0? So you literally set each one of these equal to, and you're telling me where they cross the x-intercept. Thank you. Good morning.
all kinds in there.
Thank you. You too. But now since I have this polynomial here in my denominator, now I'm turning the x-intercepts into identifying those x values to be that, because it's going to make my denominator 0 in itself because of multiplication. Those are called excluded values. You always have to identify that. Okay? Because each one of those values, the entire denominator is 0. Because if x that I solve for, if I put a negative, that means this whole thing would be 0. Does that make sense? It's like every little piece you have to look at. Okay? How are you so far? Do you have example 3 written down? Okay. Has 17x plus 25. Not really in the numerator. What about the denominator? Can we factor that out? Where x cannot be. Let me scooch this for you. What do you think my two factors are? denominator. So when I factor it, I get, I need a positive and a negative 1. So then that tells me my x's are what? Negative 6 and a positive 1. Good job. Okay. What I start doing is, yes, we have to always state our excluded values because we can't have our denominator to say what x cannot be. That makes it 0. And then we're going to start simplifying. Okay. Did you notice anything on example 2 of what your numerator was and what were the factored form that we had? Because we had an x plus 1 on example 2. What did you notice? What do we have in the denominator? We had another x plus 1, right? So that's where we're going when we look at those. We're just going to get rid of them. They just go away. Okay. And that's what all this verbiage kind of says. You have a couple of choices. You can simplify them by out, or you can just simplify them by dividing. So what they're trying to say is that, do you see how this factored form of x is also the same in the denominator? So what does that mean? Yeah, they both go to 1, right? So they both simplify. Now, in this original form, you also need to tell me my excluded values, though. So x cannot be what? Negative 2 and positive 5. So I need to still use my original. So x cannot be negative 2 and positive 5. But we are going, and we're going to say now we have 1 over x minus 5. So use the original form when it's in factored form to tell me, because see right now as it sits in simplified form, you would just think 5, right? But we also have to make sure that the original form get identified too. All right, I'm going to give you a minute. Pick on example 5 right there. We don't have it in factored form. Let me get up over here. I'm going to zoom. It looks really small on the screen. On my computer screen, it looks big. But you see that? We have a little bit of work to do this one before we can actually simplify it, which is what the instructions say. You know your x's are gonna split up, and we got to think about what kind of So what number are we picking on? My numerator, I have a 6. So I've got 1 and 6. Does that give me, can I get a positive 6, and then if I use 1 and 6? I need 2 and 3, and I need them both to be positive. Good. Because if I use 1 and 6, yeah, and have the 1 to be negative. Yeah, if I have this 1 to be negative, and that's a positive. 1 times positive 6 gives me a negative 6, and I need a positive 6 to sit out. So then I'm like, okay, I have 3 and 2, right, from my factors, and 3 and 2 work better. So I still get a positive 6, and a positive 5x when I boil the inside and the outside.
So x can be a negative 3 or a negative 2? Or does that not matter?
The what? No,
X can't be negative 3 or negative 2.
it can't be negative. Neither one of them. No, you got to look at what signs you have here. So when I look at this middle term, and if I do 3 times x, I get 3x. That's my inside. And then when I add and do the outside side, I get a positive. So they're both positive. Now the other way, one was going to be negative. Yeah, that works for positive 5x, but 6. Yeah. So that would spit out a negative 6. It's always good to double check sure. Okay. What do you think about for the, what do we got, 8 and 12? 2 and 6? Yep. They all positive? Yep. So I have a 6x here and a 2x. That does give me my 8x. And then if I take x times positive 2, I do get a positive 12. So I know I'm good there.
So our x can be negative 3 or
So my excluded values, right? I can't have a negative 6 and I can't have a negative 2. I can't hear you. What'd you say? Denominator.
just
Right. Because 0 divided by any number is just 0. But I can't divide. Alright? I need to simplify this, so how can I simplify that? My x plus 2's let's go. And then all I have left is x plus 1. I'm sorry, x plus 3. All over x plus. That's my simplified form. You don't have to put the parentheses since that's all I have there. But I always put them there just if I had another term, but just whatever. Just whatever. This is what we had done last week. So when I'm looking at this, if I was saying, if this was just my problem, okay, and we were still working in last unit, I'd say, all right, tell me what my x-intercepts are. So I take each chunk, each factored form, and I would set it equal. So when I solve for 0 at negative 6, I know that graph is going through. That's the x-intercept.
Yeah, I know. Okay, how did you only get 2 if there was 4 parentheses?
Yeah, we're only looking at the denominator because any number, and if I have a 0 in the denominator, if I'm dividing it by 0, because 0 times any number cannot give me any number.
Okay.
So you can't divide by 0. So in this denominator, now it's a whole polynomial, right, that we're dealing with. So I have to look at all those x-intercepts, and I can't have those to be 0. Okay? All right. What's next? Let's see. All right, I'm just going to show all of these. There we go. Can you see that? Okay. Give it a minute. I think this is. Yeah, like these 4 questions are it. Yeah. What'd you come up with on number 6? The numerator? Yeah. Sounds like you said denominator. When you said x minus 4, he's talking about the numerator. Okay. Thank goodness these are binomials with our 81, so these are pretty nice and sweet. So you said you got what? Minus 4 and yeah. Okay. Now we're going with a 2. It's negative. And then you get a positive. Yep, so 2 needs to be positive. But my 1 negative. So my excluded values are going to be what and what? What? Negative 2 and positive 1. So x cannot be negative 1. And now I'm ready to simplify. I got 16. I have to pick on that one in order to get a, well, I got a negative 16 and I got a negative 6. 4 and 4, does that give me 6? No, so I've got to use, what's my other one? 8 and 2. So I have an 8 and a 2. And I need my number to be negative because I need a negative 6 to spit out of that. And so I need 2 to be positive. So what numbers are we going to pick on 8? Yep, we got 4 and 2. And I negative 2. So same thing, right? I need 4 to be negative, my largest number, and this to be positive. So now I can see my excluded values. So x cannot be a positive 4, because 4 minus 4 would give me 0. And then it cannot be a negative 2. How'd you do on that one? Okay. That's actually supposed to be a cube right there. That numerator is supposed to be x cubed. And then, yeah, I really messed this one up. What I get for and then you got to ask yourself, this was probably the biggest complaint I saw, or not complaint, the biggest question that I was asked last week. I had that on top. Do those two terms still have a GCF involved for my numerator? Yes, because the left term has how many x's? My right term has an x, so they are still sharing a common term, right? Or a common factor. So when I do that, okay, so I pull out an x, that leaves me x squared minus 49. Then I should go to something else. I get difference of squares. I think those are a lot easier than the cubes. With the cubes you have to do so, but with these it's minus. Alright, so think about what you need to do. Am I in your way?
Oh,
No. Oh.
like a worm.
Alright, so what? Don't forget to bring the x with it too. So you're gonna have three different factors up top. So times x plus 7 times x minus 7 is 7, right? Okay. And just because of space, I'm just gonna rewrite this. Okay. So now that we have factored out everything in my numerator, now I can go ahead and pick on my denominator. It looks like we've got 7, and then I take out of that. So the only fact that 7 has, because it's prime, is 1 and 7, right? Okay. That was kind of nice. Now I need 7 to be negative, but I also need 6 to be negative. So one of them needs to be negative, and that means that the large number will be, because 6 needs negative. So that looks like x cannot be a positive 7 and a negative 1. What you see? And then I get rid of my x minus 7.
Why are we about the x plus? I mean, when x not, can x not be negative 7? If I'm making sense, for the things that x cannot be.
In my denominator. Because if you number divide by 0 in your calculator, it spits out an tax error for you because you divide by. Because if you go like our 3rd grade style, because you know how you can have any number. Let's just make that number. Let's just say we'll pick on 4. Divide by 0. What that means in the third grade style, remember that this 4 goes in the house, 0 comes out, right? Like that's how division works. So you tell me 0 times what is going to give me 4? It doesn't work, right? Now if we vice versa, which is when you have zeros on top, and then the 0 goes in the house, then 4 times 0 gives you 0. But this way, you can get a number from 0. You always get 0. So that's why it's meaning. Like this does produce things with the functions, and I'm sure we're gonna see the second part of this unit because they're splitting this unit up as well. So yeah, they're doing rationals first and then radicals.
I'm so excited.
Yeah. All right, 1. What do we have? 2y over y. Let's see if I did this. Okay, didn't. All right. Can't really do anything in the numerator, right? In the denominator. I always have to think GCF, right? And I do see that they both carry a y in common, and then I see because they're even, I can definitely pull out a 2, right? Look at what our numerator is. Y. So let me rewrite this. So I'm going to factor out a 2y, and then I have a 2 and another y inside, and there's a plus 3 there. Oops, I need to say y. What can it not be?
It can't be negative. Or negative y.
No, you're setting them each one and see what it's going to be. So when I set 2y to 0, I divide by 2, y is just 0, right? It'll be 0 there. So I'm going to pick on that 2y just so you can see how you get the numbers. When I set that to 0 by 2, 0 divided by 2 is 0. So I know that can't be 0. And then when I set 2y plus 3 to 0, and I solve, subtract 3 divided by 2, that's negative 3 halves. No different if you were telling me my x-intercepts. Those are the two that it can't be. Now we can